Hi, this evening we're going to talk about the rational roots theorem. Our learning target is I can find the roots and solutions of polynomials using the rational roots theorem. As you can recall, we have already been finding the roots and solutions of polynomials by graphing, by factoring, and different things like that. So this time, this is for polynomials that have a degree of 3 or higher, and it's not easily factorable, then we use the rational roots theorem. The rational roots theorem is a way to make some educated guesses at what your possible roots are. So if I have a polynomial to the degree of 4, the highest degree of 4 to the fourth power, then I have 4 roots, both real and imaginary. So that's what we use it for. Now, the rational root theorem says, and this is the formal definition here. And you might want to put definition next to it because you will see that in the vocabulary portion of any assessments that we do. So for any polynomial, the possible roots are of the following form: P over Q, or P divided by Q, where P is a factor of the constant term and Q is a factor of the leading coefficient. We use, again, the rational roots theorem when we have a polynomial of degree 3 or higher, which isn't easily factorable. So let's look at some things that we can do. And we also, remember, we combine this with our synthetic division that we learned in our last lesson. We combine that with synthetic division in order to get our solutions. Now, and we now you want to do just as we go through this, I'm putting this in Desmos so I can check my roots and make sure I'm on the right track. And so Desmos gives me what the roots are. Remember, the roots or the zeros or solutions, and that I should have included that up there too. The possible roots, we also say zeros or solutions. So those terms are used interchangeably: roots, zeros, solutions. We talk about zeros when we're talking about graphing, where the graph crosses the x-axis, that's where y is equal to 0. Solutions are when we have something of this format, where it's an equation. Okay, and we can solve this by just graphing this part without having the equal 0, and that would actually give us that. So now let's look at this one. Our leading coefficient is 1. So all the factors of Q would be just 1. Now let's look at P. P is all the factors, remember from our definition, P is all the factors of the constant term. Our constant term is 20. So what are some of the factors of 20? Of course, plus or minus 1, positive or negative 2. 3 is not 1, so it's 4, plus or minus 5, 6, 7, 8, 9, plus or minus 10, and plus or minus 20. Now, if we want to put this in the format P over Q, all of these terms would be over 1. So we don't really have to write that. But if our leading, and I'll show an example where the leading coefficient is not 1. So now these are all my possible roots, plus or minus 1. Now let me remind you, I always try positive 1, positive and negative 1, positive and negative 2. Let's start out with 2. Let's say our root is 2. But when we set up our synthetic division, we're not going to divide by 2. Remember, if the root is 2, that means x minus 2 equals 0. So that's what we want to do. And then we get x equals 2. So we want to try a -2 here. In our synthetic division, just as a reminder, we put the coefficients of each term from our highest exponent down to the constant term. So that's a 1, -8, 11, 3, 2, 1. And just as a quick question, what would we do? Let's say the x squared term was missing. What we would do is put a 0 in for it. So remember with synthetic division, we bring this 1 down, we add and subtract inside this box. On the outside, we multiply. So -2 times 1 is a -2. We add these together. -2 times -2, -10 times -2 is a +20. And we can see without even, our remainder is not 0. Without even adding, we could see at that point we had to multiply 31 times -2. That was not going to be a solution. So let's try to see if -1 is a root. So if -1 is a root, we're going to divide by +1. And we're going to put our coefficients here. Let me move that down just a little bit. So we're going to bring down this 1. 1 times 1 is 1. Add these. -7 times 1 is -7. 11 minus 7 is 4. And 4 times 1 is 4. So that's not a solution. Let's try -1. And I told you wrong. If the root is, so let's do this one. So let's try -1. So this is 1 times -1. We add these together. We got -9. -9 times -1 is +9. This is 20. 20 times -1 is -20. And that's 0. So one of my solutions is x plus 1, because I said that backwards right here. It's x plus 1 because my root is a -1. If I set x plus 1 equals 0, I'm going to get x equals -1. So I said that backwards up there. Okay. Of course, you know Miss Sledge makes mistakes. So now what do we do with the rest of this? So we started out with a polynomial to the degree of 3. So this is going to be our x squared term here. So we got x squared minus 9x plus 20. Now we can factor that to x and x, factors of 20 that add up to -9. So I have factors of +20 that add up to -9. And I think that's going to be -5 and -4, because if we multiply those, it's going to be +20. And if we add them together, it's going to give us -9. So we have x minus 5, x minus 4. And so now we set all of these equal to 0. Does anybody remember the name of the property? Right, zero products property. So here's our x equals -1 root, x equals 5, and x equals 4. And these are one step, so we don't have to go through that, subtracting 1 from each side, adding 5 to each side, adding 4 to each side. Remember, I told you at this point, we need to be fluent in solving equations. Okay, now let's look at another one. This is another example. I want you to try it first and then come back and compare your solution to what we did. So now P over Q, and Q is equal to 1. So all of these are going to be over 1. And it's real nice when your leading coefficient is 1. Your possible solutions are simply just the factors of your constant term. So we got a -24, of course, plus or minus 1, 2, 3, 4, 6, 8. Remember, we got to be fluent in multiplying. Okay, 9, 10, 11, 12. And I think we got, and then 24. Okay. So I'm going to try -1 first. And remember, coefficients, 3, 2, 1, constant of my terms. So -1, that's going to be 0. And remember, here we multiply, inside of here we add. And then we add these together, -10. So we have a remainder, so 1 is not a solution. Let's try -2. And it's really just making an educated guess on what the solution. Now, if neither one of these work, I'll go back and do +1 and +2, then go 3, 4, 5, so forth and so on. I'm not 5, 3, 4, 6. Okay. Bring that down. Now we're going to multiply. Add these together. We're going to multiply again. -1 times -2 is a +2. This is going to give us a -12. I think this is good. -12 times -2 is a +24. When we have a remainder of 0, -2 is a root. Why did I change that to plus? Again, if I solve this if I set this equal to 0 and subtract 2 from each side, I'll get a root of -2. So inside here, it needs to be the opposite sign. So now we have this here, x squared minus x minus 12. So now I want factors of -12 that add up to -1. I think we got a 4 times 3, and if we make that one negative, that's going to be one of our solutions. So x minus 4, x plus 3, and they're all equal to 0. And then when we set each of these equal to 0, we're going to get our roots. Remember, the zero products property says if several factors are 2 or more factors are equal to 0, either one or all of those factors are equal to 0. So this is going to be x equals -2, add 4 to each side, x equals 4, subtract 3 from each side, x equals -3. And this, we started out with a cubic equation, and we have 3 real solutions. Now, sometimes some of those solutions could be imaginary. Now, you're probably asking what happens when the leading coefficient is not 1. I am not going to go into all of that today, but I'm going to show you how we would do it. That's our next lesson. So P, that's my numerator, going to be factors of 12. And you should be fluent in this part right here. 6 and then plus or minus 12, okay? 2 times 6, 3 times 4, 1 times 12. And then Q, my denominator, is factors of 10. I was going to put a 3. It's not a 3, it's a 5. And then plus or minus 10. So your possible rational roots, 1 over all of these numbers. P is your numerator, so plus or minus 1 over 1. So we can just write that as 1. And then plus or minus 1 over 2, 5. Am I really going to write all of those? Yes. Okay, now we start with 2. So we get a 2, 2 over 1. 2 over 2 is 1. We already have that right there, so we don't need to repeat it. My plus or minus looks weird. Okay. And then 2 over 5. And then 2 over 10, which is 1/5 right here. So we don't repeat that. Now we go to 3. So it's not as bad as you think. So we got plus or minus 3 over 1, 3 over 2, 3 over 5, and 3 over 10. And you continue with all of these until you get to 12 and get all your possible roots. Okay? Now, when you simplify, if it's a number that you already have up here, don't write it again. Now, what I would do in this case is that I would graph this one and get my possible roots. Now, once you find the root from here, once you finish writing all these terms down and you practice a few roots and see if you get 0 as your remainder, then you're going to have a cubic equation, which you cannot factor. So you're going to have to do this process again. P over Q, find the possible roots. So the easiest way to do this is to graph this first, but we'll handle that in the next lesson. It can get messy, okay? But good luck with the practice problems, and let me know if you have any issues working these, and we'll get in small groups and figure it out. All righty.